There we go. Okay. So we're starting with fractions for one. It's called Introduction to Fractions and Mixed Numbers. Introduction to Fractions and Mixed Numbers.
Hey, Ms. Garrett, I'm still having technical difficulties with my computer again, so I'm on my phone today until I figure out what's going on. I'm gonna be on my phone.
All right, as long as you're here, it doesn't matter what you're on, phone, computer. You're good as long as you're here.
Okay. Okay.
I lost all your beautiful faces on my computer somewhere. I'm finding them. Ah, there they are in the background. Okay, good. Okay, here we go. Hey, so a fraction, we're going basic, like basic, like basic. So if you've never gotten fractions or fractions just aren't your thing, this is your time to get them. Or if you know fractions pretty well, this is just gonna be a little introduction, maybe something you haven't done in a while, you haven't seen, but it's just very basic. Okay. Okay, so something about a fraction. A fraction, the most basic thing is what is a fraction? A fraction, I like to think of it as a part over a whole. It consists of a numerator divided by the denominator. And the numerator is the part and the denominator is the whole. Hey, when you see a fraction bar like 1/2, it is the same thing as saying 1 divided by 2. A fraction bar is just a shortcut way to say division in fraction world. It just means division. So if I have 5/8, this is my numerator, and this is my denominator. And when I say 5/8 or 5/8, I am saying 5 divided by 8. And if I think of it as part of a whole, 5 is the part of a whole of 8. So 5 is part of 5 out of 8 means I have 5 things out of 8, whereas 5 out of 8 as part of a whole. Okay, one way that we can look at fractions, and if you think really, really far back in prior education, when you first learned fractions, we did a lot of modeling, meaning a lot of pictures. So we're going to look at fractions with like figures. Okay, so one way to look at fractions is using shaded pictures. Okay, examples. One, if I have a picture, now I have to imagine some of my pictures. I'm not really good at drawing, but let's see if I can draw this right. Like a pie, if you want to think of it as a pie or a pie graph. If I have a pie graph, if I count how many pieces of this pie, I have 1, 2, 3, 4, 5, I have 8. So out of 8, I can show you, I can represent a fraction with this pie graph by, whoops, I didn't change my color. There we go. By shading certain parts of my pie graph. So out of 8, 8 is my whole, 8 pieces make a whole pie graph. I am representing a fraction here, and this fraction would be 5/8 or 5 out of 8. You can think of that way too. 5 out of 8 pieces, which means 5/8 or 5 divided by 8. All means the same thing. 5 is my part. 8 is my whole. You can do all kind of pictures. I have to be a pie graph. I could do a triangle. I'm going to cut this particular triangle into 3 pieces. Now, they're all supposed to be equal pieces. My drawings aren't perfect, but think of that. Everything I draw is equal pieces. So I'm not talking about a big piece and a little piece. They're all supposed to be equal pieces. So if I shade these 2 pieces, I did have a whole of 3 pieces, a whole made up 3 pieces, but I only shaded, whoops, where did my thing go? I lost it. I know I shaded 2 of them. And I only shaded 2. So my fraction represented by this picture is 2/3. I shaded 2 out of 3 pieces, part over whole. Now, okay, I guarantee it is not gonna look the same, but they're meant to be identical identical sizes, identical shapes. So hang with me. If I, let's see, I'm grabbing our color, let's see. Okay, so I have 1, 2, 3, 4, 5, 6. 6 is my whole, and I just shaded 5 of them. So I can represent 5, 6 by this picture here. Just means the part is 5. The part I shaded was 5. Shaded part over my whole of 6. I had 6 pieces total. Another way to think about it. I'm trying to give you everything a way I could think about fraction in my head. And put it down on paper. So it looks like a 1 more. That's a different way you can represent a fraction. All these little different pictures. Okay, so I can do now again, these are all the same size, even though mine are going to look a little different. Okay, so, and I'm going to shade. Okay, so I had, hopefully I did 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I did 14. How many did I shade? 1, 2, 3, 4, 5, 6, 7. 7 out of 14. So 7 green out of 14 total. Another way to think about it, I have 7 green out of 14 total. And that's why it'd be part, the green is a part and the 14 is a whole. Now, yes, we always simplify fractions, but we're not there yet. As soon as I get to simplify fractions, you won't see 7 over 14. Those of you who remember how to simplify your fractions, it'd be at 1/2, but we'll get there. But that's what my picture represents, 7 out of 14. All right, I want to give
Let me
you,
get number 4.
what's that?
I was gonna say, let me get number 4 real quick before you change the page.
I'm not, I'm adding to it.
Oh, okay.
All right, so this is, oh, absolutely. Let me erase this. This is for you guys. I want you to try. So you try. Now, when I say you try, I'm going to give you a fraction and I want you to make a model. These are called models. A picture, a geometric picture, we have shading parts. Does it matter what model you make? No. You can make a pie, you can make a triangle, you can make bars, you can make circles, you can make diamonds, whatever you want. but I want you to try making your own model. So whatever comes to your mind first, that's what you should draw. So I have two of them for you to try. I want you to try to make a picture model. Make a picture model of each fraction that I'm going to write down. I'm going to do two of them. So I want you to try 3/5, and I want you to try 4/9. I didn't make them too big, so you don't have too much to draw. So just take a minute, draw a model of each. It doesn't matter what, again, doesn't matter what you create with it. Just make a picture representation. And I'll give you a minute, sorry. Oh, shoot. I logged off and my screen sharing stopped. Hold on. There. I forgot if I changed my page. I have somebody who's logged in as Galaxy, I guess a phone. That must be Kia. Is that you? That must be you. Yeah, I'm looking. That's you. Never mind.
Yeah, that's me. That's why I
Yeah, I
was
got
saying
you.
I was having to.
Yeah, that's
Yeah,
all
I was
right. So I
having
make
issues with my
sure,
computer.
yeah, so make sure you don't, I don't mark your absent. That's all. I got you.
Okay.
Okay, so what kind of picture can you make? Anything you want. I'm gonna make something different just to show you something different. If you can sort of have, if you're real artistic, you can have all kind of fun with this. So I'm just gonna make little triangles. And then I'm gonna color them. I got 2, 3. Like that could be a model. It could be anything that has 5 things and you shade in 3 of them. And then let's do 4 out of 9. Let's see. Let's do, I don't know, let's do little squares. Okay, again, I know we can't draw them perfectly, but they're represented to be the same size, the same shape. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you don't, as you've seen before, I did it on purpose. You don't have to put them in order. You can shade in any wherever you want, as long as just 4 of them. And that would be 4 out of 9. 1, 2, 3, 4, 5, 6. Yeah, I did 4 out of 9. So how we do? Anybody have any questions for me? I'm going to hold for a minute so you can finish writing down what you need to write down, but I'm going to add a page here in a second. Any questions? Everybody good? Awesome. I am ready to turn the page, or sorry, add the page. Okay, I'm adding a page. Hey, now, of all the things in mathematics that I can think of, fractions are the most real life. Anything, you're gonna think, what? Fractions aren't, they're so foreign. No, they're not. They're like your whole life. Okay, so let me give you a couple examples. So fractions in real life, everyday life that you use every single day. These are examples. And just a couple to show you how like you're every day you wake up is like fraction day. Okay, 1. You get 8 hours of sleep. at night? What fraction of the day is this? Yes, it's a fraction. There are 24 hours in a day. You sleep 8 hours a night, 8 out of 24 hours. A fraction. Yes, again, I know we can simplify it. We're not there yet. A fraction. So the amount of hours you sleep every night is a fraction. The amount of hours that you eat something in a day is a fraction. The amount of hours that you spend cooking is a fraction. The amount of hours that you spend on yard work is a fraction. Your whole day is a fraction of part of your day. It's a fraction. 2. Work. Your team of 3 people worked on a project that took 5 hours. In total, the whole project will take 8 hours to complete. What fraction does this represent? Now I put, whoops, ooh, that was interesting. I just put my little finger pushed a little cute little thing there, nice and green. Okay, so I put an extra number in there, the team of 3 people. It has nothing to do with how long you took on a project, right? So your project took and worked on a project. Your 3 people together worked on a project for 5 hours. In total, the whole project will take 8 hours. What fraction does it represent? So far, your team of 3 people worked 5 hours out of 8 hours, or 5/8 of the time. Everything in life can be represented by a fraction. Because it is part of a whole. Everything in life. Think about everything you do every day. It's part of a fraction. Everything. Now, I hate to talk about gas. I really do hate to talk about gas, but because it's so darn expensive right now. But do you ever notice that gas is like, it has a fraction in it? I'm trying to like picture in my mind. Is it 0.9, 9/10? So I don't know how much gas is. Let's say it's $4.67, something like that. And there's like a little 9. I can't, in my mind, I can't picture it for a second. And 9/10, that's your price of gas. If you ever look for that little tiny 9, or I think it's always a 9. It's a fraction. You're actually paying almost $4.68, but they put $4.67 to make it seem cheaper. But that 9/10 is part of what you're paying for your gas. They just don't really highlight it. When you go to gas station next, look for that little tiny 9, and you'll see it. And that's a fraction. So even your gas, they hide the price with a fraction. Very interesting. I always wondered when I was a kid what that little 9 was, until I got to be older and I'm like, oh, that's a fraction. Hold on, where are you getting gas for $4.31? I don't know. I don't have $4.31 and 9/10. Yeah, $4.30. I wish it was $4.31. Yeah, I know. Physics, yeah. Navarre. You know where the cheapest gas was? I went to Navarre Beach this weekend, and it was the cheapest gas of anywhere around. No kidding. So if you, I know it takes a trip to get to Navarre, which means it takes gas to get to Navarre, but I was shocked. Right there, Tom Thumb and Navarre was the cheapest around. I could not believe it. Cannot believe it. Anyway, look for that little 9, and that's part of a fraction. I missed from the Tom Thumb. Yeah, you're okay. Is that where you got, Jacinda, is that where you got your gas? Because that was the cheapest around. To ride a bike. Yeah, I know. We should ride bikes, save energy, right? It's crazy. I don't know how anybody affords it. All right, I'm going to switch the page and add a new page. And then we're gonna talk about definitions. And that was bad. I know. I hate to talk about gas. One thing about online class, we don't have to drive anywhere, right? Oh, it's more inland, really. Wow. Okay, definitions for fractions. 1, proper fraction. It is important that you know what these are. Proper fraction. A proper fraction is a kind of fraction that we want to work with. A proper fraction is a fraction where the numerator is smaller, or you can think of it as less than the denominator. These are the kind of fractions that we want to work with all the time. Things like 2/3 is a proper fraction. 5/9 is a proper fraction. 124 over 125. I know I'm getting away, but that's the idea. The numerator has to be smaller than the denominator. So we have proper fractions. We also have improper fraction. Improper fractions. All right, so that's like the opposite. A fraction where the numerator is larger than, I can say bigger, so I used smaller before, bigger the denominator. So like 25 over 6 is an improper fraction. 142 over 67 is an improper fraction. Anything with a numerator is bigger than a denominator. 14 out of 13, all improper fractions. We don't like improper fractions. We try to simplify them. Oops. And we'll talk about that as part of my next, that's my next word. How we simplify improper fraction. 3, mixed number. Also has to do with fractions. So a mixed number contains a whole number and also a fraction together. You can think of it as a mix of whole and a fraction. That's really what it is. It's looking at a number as a mix of a whole. That's why it's called a mixed number. It's a mix of a whole and a fraction together. Actually, let me put that word together there. I like that better. Okay, the most important thing about mixed numbers is mixed numbers are greater than 1. They're all bigger than 1, mixed numbers. An example of a mixed number would be 5 1/2, 6 2/3, 142 and 2/7, something like that. They're all mixed numbers. Okay, I'll pause for a minute, give you a chance to just sort of catch up if you're behind just for a minute. Any questions so far while I'm holding up for a second? We're going to do some pictures of mixed numbers next.
I'm
Yes.
almost done writing this down.
Okay, I'm just moving this last one up like that. Okay, let's look at a couple pictures of mixed numbers. How would you represent that as a picture? Representing a mixed number as a figure / picture. They can be called figures too. So let's say I have 2 1/2. How could I represent that in a picture? Well, you could do something like this. Again, they're supposed to be the same size, even though mine's not. Let's just say I go like this. I like this idea. Let me fix that one though. All right, how would I take that and represent 2 1/2? Well, I know I have 2 holes. So I have this hole, I have this hole, but then I only have a half extra. So that's my 2 holes with an extra half, 2 1/2. Again, it doesn't have to be rectangles. It could be any kind of picture that you want to draw that represents your fraction. How can I represent 4 3/4? Well, let's do, let's do circles. 1, 2, 3, 4. I need 5 because I need 4 plus a little bit, right? So I'm going to make them all into 4 pieces. I don't really have to make them all 4 pieces, but just to sort of kind of give you an idea. So I have 4 holes. So 4, my piece is going to get covered up anyway. 2, 3, 4, and then 3 out of 4 left. So I have my 4 holes and I have 3 out of 4 for 4 3/4. And you should notice it's almost 5, right? We're only a quarter short of 5. Okay, I'm just going to make sure you guys have a second to do that. While you're doing that, I'm going to age myself really big time. I remember when gas was $1 something. Seriously, $1 something. It wasn't even that long. It was 2 something.
I remember when it was 99 cents.
Oh, good. I'm not the only one. Good. I do too. Oh, gosh. And we thought that was expensive then. I can't imagine. When my kids were younger, we did a big trip out west. That's why you're writing down. And what part of our trip was California, and we went to California, and this was, oh my gosh, 14 years ago. And we crossed the California line to go to California, and gas was like $4.67, $4.92, I forget, something crazy like that. And we thought, oh my gosh, that's insane. And now look where we are. Of course, their gas right now is probably $7 or $8 a gallon, but still. Woof. Okay, I'm adding a page. All right, so there is one other way we can represent fractions, and that's with the number line. So let me put black to black. Graphing a number on a number line. So it's another way to visualize a fraction. So it's another way to visualize a fraction. Okay, so let's say I want to, number one, I want to, well, actually, I need to put my directions first for all of them. So we're going to graph each fraction on a number line. We're just going to do a couple of them. Now we'll do one. Okay, 5/7. So I'm going to make a number line. Now, the thing is, though, you have to look at the denominator to know how to do your number line. So my denominator, my whole is a 7. So when I make my number line, I'm going to start with 0. And I know it's between 0 and 1 because 5/7 is smaller than 1, right? Because 7/7 would be 1. 5/7 is smaller than 1. So I'm going to have to, between 0 and 1, I have to make 7 equal pieces. I know mine probably won't look like it, but hold on a second. Okay, so 1, 2, 3, 4. I got to move my 1. I'm trying to do even, but it's not working out here. Hold on. So 1, 2, 3, 4, 5, 6, 7. So I should have 7 pieces. Should I have 1, 2, 3, 4, 5, 6, 7? Yes. Between 0 and 1, 1, 2, 3, 4, 5, 6, 7. I have 7 pieces. Perfect. Okay, let me erase this. Now, if I want to represent 5/7 on a number line, I would go to the 5th one. So 1, 2, 3, 4, 5. This is 5/7. And because there's a denominator of 7, I have to go and make 7 equal pieces to show my 5/7. Let's do one more like that. 2. How about if I do 4/6, which is not simplified, but that's all right. We're not there yet. Don't worry, we will be. So 4/6 is also less than 1. But instead of 7 pieces, my whole is 6. So I'm going to do 6 pieces. 1, 2, 3, 4, 5. Now that's 1. So that should be 6 pieces. I say 1, 2, 3, 4. Okay. So I broke between 0 and 1 into 6 equal pieces. And I want 4 of the 6. So 1, 2, 3, 4. So, whoa, 1, 2, 3, 4. I did that wrong. Hold on. I'm adding it now. It's not right. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, totally wrong. Hold on. I didn't count right. That's my 1. 1, 2, 3. No, am I right? What am I doing? 1, 2. I can't count. Let's go back to where I was. Hold on a second. Miss Garrett can't count. Or she's seeing things. I think it's more I'm seeing things. Okay, so let's do this again. I was right the first time. 1, 2, 3, 4.
Great.
There you go. 4/6. Okay, let's look at a mixed number. How would you do a mixed number? So let's say I have 3 1/2. Okay, so now we have more than 1. 0, 1, 2, 3, 4. But I'm counting by, I also have a half. So I'm going to put a little tiny tick mark halfway between to represent a half of each of them. So this is really, I'm gonna write it here so you see it. This really represents a half. This represents 1 1/2. This represents 2 1/2. And this represents 3 1/2. So if I want to plot or graph 3 1/2, I'm going to put my point at 3 1/2. Oops. And the last one I want to show you is if we had something like this. How would you graph 4 out of 4? Okay, well, if my denominator is 4, so 1, 2, 3, 4. So 1, 2, 3, 4. So 4 out of 4. So this is really like 1/4. That's 1 out of 4. This is 2 out of 4. This is 3 out of 4. But 1 is really 4 out of 4. So they represent the same thing. So that would be my 4 out of 4, which is just really 1. Yeah, David asked a question. This is very interesting too. Mrs. Carrot, don't they still pump one's gas in New Jersey? Yes, I have never pumped gas into my car till I moved out of New Jersey. We are not allowed legally to pump our own gas. We have attendants who pump our gas for us. Isn't that crazy? I think it's one of 2 states. I forget the other state. Okay, so I have someone who's not understanding this too well. So basically what you do is you take your denominator. Let me change my color so it stands out. You take your denominator. 5/7 is less than 1 because 7/7 would be 1. So 5/7 is less than 1. So between 0 and 1, you're going to make 7 slices or 7 pieces. 1, 2, 3, 4, 5, 6, 7. You don't count to 0. That's where you start. So this would be 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, and this, like you saw in the last problem, would be 7/7. But I am just graphing 5/7. So at 5/7 would be my point. That represents the 5/7. Same thing with anything with a numerator and denominator. 6 is how many pieces I need to put between 0 and 1. Why between 0 and 1? Because it's less than 1. The numerator is smaller than the denominator, which makes it less than a whole. So I would do, this is 1/6. This would be 2/6. This would be 3/6, 4/6, 5/6, and 1 represents 6/6, which means a whole. So my 4/6 would be what I have graphed right there. So you have to take the denominator and you have to break up your number line according to that number line, to that denominator. Now, 3 was 3 1/2. So I had to at least have a 1, 2, and 3. And then I have to add another half between 3 and 4. You didn't have to put the halves. You don't need these, but I wanted to show you how they're all sort of lined up. But you could have just done, let me erase these for a minute. Whoops, let me erase that one. Let me go back to black. 1. You could have just graphed this if you prefer that way. 1, 2, 3, and between 3 and 4, you can graph a half. So I hope that helps. Yeah, my brother's, yeah. Jacinda said my brother used to live in Jamesburg and they said the same thing. Yeah, I have not pumped gas in my life. When I went to Philadelphia for some reason, because I didn't live far from Philadelphia, I lived in South. When you think New Jersey, you think like city. No, I lived in a farms. Like this is busier than any town I lived in. I lived in a farm. I have a farm across the street. We had beautiful, like scenery. It was beautiful in New Jersey where I lived. Very, really rural town. Anyway, But yeah, so anyone, only when I went to Philadelphia for some reason or Pennsylvania that I have to pump gas. And then I still made my husband do it because I didn't know how to do it. So I learned to pump gas when I moved here. Isn't that sort of like weird, huh? Yeah, weird. Okay, so now we get into the big part. How do we simplify fractions? Okay, so let me add a page. Simplifying fractions. Every fraction has to be in simplest form. So every fraction must be in simplest form, which means, okay, let me write that again. So I don't even like how that looks. Let me move that. Hold on. Simplest form, which means it cannot be reduced anymore. So basically, we're talking about dividing. That's what we're talking about. We're talking about division, making a fraction simplest terms, simplest form. Okay, so my directions would just be, if I gave you this problem, my directions would just be simplify. And then we're going to do a whole bunch of simplifying. Now, when you have a fraction, there's really, I'm thinking in my head, two ways you can think of simplifying it. So my first one's going to be 9 out of 9 or 9 over 9. If I have 9 over 9, I really have 1. We just talked about it, but you can think of it as doing it two ways. You can think of it as taking 9 over 9 and I can divide both of them by 9. So whatever you do to one new part of the numerator, you got to do the other part. So if I divide 1 by 9, I got to divide both of them by 9 to keep it equal. And 9 divided by 9 is 1 for my numerator, and 9 divided by 9 is 1 for my denominator, and 1 over 1 is just 1. That would be the simplest form, 1. You can divide that way, or you could actually think of it as dividing long division if you prefer that way. How many 9s are in 9? 1, 9, 0 remainder. My answer is 1. I will tell you though that this is the way that you really want to do it when we get into bigger problems. You want to think, what can I divide? This is what you're going to think. Ready? Actually, I'll put it up here. I'll change my color. This is what you're going to think. What can I divide the numerator and denominator by? That's what you're going to think. What can I divide the numerator and the denominator? It has to be both. Whatever you do to one, you have to do to the other. Two. 6 over 10. Okay, number one, I always look for even numbers. Isn't 6 and 10 both even? I know at least minimally I can divide by 2. I might be able to divide by more, but I know at least I can divide by 2. But if I divide 6 by 2, I get 3. And I can't get a 3 out of 10. So I'm going to divide both of them by 2. And if you ever don't know what to divide by, whoops, and you know they're two even numbers, just start dividing by 2 and keep going till you know you can't do anymore. So 6 divided by 2 is 3, 10 divided by 2 is 5, and that I cannot simplify anymore. I can't divide both of them by anything other than 1. That's not going to help me. Done. I'll put some negative number in there. Negative 5 over 15. what can I divide both of them by? I can divide both of them. They're all multiples of 5, right? 5, 10, 15. I can divide both of them by 5. And my answer, since it's a negative, it has to be a negative. I only have one negative. 5 divided by 5 is 1. 15 divided by 5 is 3. And notice when I wrote the problem, I put the negative in my numerator. And when I wrote the answer, I put it in the front. It doesn't matter where it is as long as it's there. Normally, it's either in the numerator or in front. You can also put it in denominator if you want, but it's not really a way that a lot of people write it. Four. Negative 13 over 0. I can't divide either of them by anything, but this is here to remind you that you cannot ever divide by 0 undefined. This is the only one that'll be undefined when you divide by 0, because you cannot divide by 0. Let's say I have 9 over 27. Again, it's smaller than 1, right? Because the numerator is smaller than the denominator. We're going to get into all that in a few minutes with it not being, but I know that 9 times 3 is 27. I can divide both of them by 9. And what do I get? My numerator becomes 1. My denominator is 9 times 3 is 27, 1/3. I stopped circling my answers for some reason. Let's do a couple more. Let's do 12. Go ahead.
What if you get a problem like that and you're saying you dividing both of them by 9 and your answer is just 3?
The answer had to be 3 if
Yeah.
it was the only reason that particular problem would be 3 is if it was 27 over 9, which is an improper fraction. That would be 3 because I would divide this by 9 and divide this by 9. And you have to follow what's your numerator and what's your denominator. So 27 divided by 9 is 3, and 9 divided by 9 is 1, and that would give me the answer of 3 if I simplified. So it's really important you
okay.
follow where that number is, like where it is. So 27 divided by 3 was in my denominator, so that's where my 3 has to go, and 1 has to be in my numerator, the way I wrote it. But this one would be when it's just 3. Okay.
Oh, okay.
All right, 12 over 15. Well, these two, they're not both even, right? 12 is even, 15 is not, but I can divide them both by 3. I'm going to do one next that I'm going to pretend I don't know how to do it, and I'm going to show you how to get through it. Okay, so 12 divided by 3 is 4. 15 divided by 3 is 5. Is there anything else I can do? No. 4 over 5. 7. Actually, let me do one first. How would you simplify -5 over 1? Well, I don't really have to divide anything. Anything divided by 1 or anything multiplied by 1 is itself, right? So it's just -5. Okay, so let me think of one where I can pretend I don't know how to do it. Okay, let's do 28 over 30. All right, so let's just say I don't know what to divide by. Okay, but I know they're both even, right? So I'm going to start by dividing both of them by 2, just because I know I can. I know they're even numbers. I can divide by 2. Okay, so 28 divided by 2. So what is half of 28? 14. And 30 divided by 2 is 15. And unfortunately, we're done. That's not what I wanted. Let me try one more. Okay, let me get really creative. Let's see. 50 over 120. Now I'm really getting creative. Okay, so again, I'm going back to just evens. I just want thick evens. actually, let me. Yeah, okay, let's just say I divide by 2. I don't know what else to do. I don't know, I'm stuck, I forgot what I'm doing, I just want to simplify. I know they're even numbers, so divide by 2, 25. If I divide 120 by 2, that's 60. And now we look at what you have. I have a 25 and a 60. They're not even anymore, but aren't they multiples of 5? So now I can divide by 5. So 25 divided by 5 is 5. And 60 divided by 5. Okay, so let's say I don't know what that is either. Because, maybe I don't. That's 1, bring down to 0, 2, that's 10. Okay, so it's 12. Can I simplify any more? No. So don't be afraid if you have a big number that you have to simplify, a big fraction you have to simplify. Don't be afraid of dividing by something and dividing by something again, or even do it again. Just till you get to the simplest term. Don't think you have to think right off the bat, the biggest number you can divide by. Sometimes that's even hard. Sometimes it's hard for me too. I have to do like maybe try 1 or 2 things before I get it. Don't be afraid to do that. All right, questions on that? Okay, I'm adding a page.